Okay, so adding and subtracting fractions, we have to have the same what? Denominator. Bottom of the fraction's got to be the same. So we'll do some baby problems. My boys call it. Anything, time something easy, it's baby stuff. So baby problem. 7 over 4x plus 3 over 4x. The denominator's already the same, right? So what do? Add the numerators, right? If they're like terms, put them together. Are 7 and 3 like terms? They're both just plain numbers, right? So we just add those together. That ends up being 10 over 4x. Biggest mistake or most common mistake I see when I do this in Algebra 1 or Algebra 2 is you want to get 8x on the bottom, and it's not. It stays 4x. So 10 over 4x, but then we have to think about what we did in the first section, section 4, and that's simplify. We always want to reduce our fractions if we can. 10 over 4x will reduce because both of those are divisible by 2, so that becomes 5 over 2x, and there's our final answer for that one. This is the baby stuff. It's easy because it's already set up for us. 10 over x plus 3. This looks a little bit more Algebra 2-ish, but it's still baby stuff because the denominators are already what? They're already the same. So that means we don't have to do any work to get them there. So we just do the work. 10 minus 17, which would be negative 7 over x plus 3. And does that reduce? No, the x plus 3, the x and the 3 are tied together. It wouldn't matter what kind of number that was on top. You could not reduce it unless there was an x plus 3 as a factor up top. Okay, so really, really easy when the stuff's already set up for you. Let's get something a little bit more Algebra 2 level. Still probably, I would still probably call this Algebra 1 level. Maybe 2x over x plus 2 plus 4 over x plus 2. Denominator already the same. Are those like terms on the top, though? Not this time. We got 2x and we got a 4. They're not like terms, so we're going to write them as a binomial. It's going to be 2x plus 4 on top. And this is where some folks would say, oh, we're done. Good. No, you're not done. Because we always have to look to see if we could simplify. And this would simplify, much like the first one on the quiz, by doing a GCF on the top and get a 2 parentheses x plus 2. And on the bottom, we got an x plus 2. So these cancel each other out. And that big, ugly problem we started off with just is actually the number 2. So not getting terribly difficult yet, but we got to be able to factor and got to be able to simplify at some point here to try to get somewhere with this. Let's say we had this one. And we had 4x over x minus 3 minus 12 over x minus 3. Kind of similar, a little bit different. Denominator's already the same, so we can go ahead and do the subtraction, right? So it's going to be 4x minus 12 over x minus 3. But then we always want to check to see if we can simplify. It doesn't mean that it always will simplify, but we have to check for it. The top part is 4x minus 3, and the bottom part is x minus 3, so we get some cancellation happening. It's 4. And you got that simple, big ugly problem turns into a nice number for us. That's nice. Let's step it up just a little bit. 16x squared over 4x plus 5 minus 25 over 4x plus 5. Denominator already the same. So we just do the work on top. 16x squared minus 25 over 4x plus 5. What do we know about the numerator? It's the difference of squares. That's right, Trevor. So how does it factor? Good. And then 4x plus 5 on the bottom. Cancel out one of those, and we get 4x minus 5. Final answer. Being able to add and subtract these and then simplify them is going to make things easier when we do the next section on Monday, where we're actually solving equations with these things. So if we can't simplify it, it makes our equations much more difficult. So being able to simplify is a big part of that. All right. Well, so far we've been real nice to us, and they've said, okay, the denominators are already the same. Well, let's get to the ones where they're not. Okay, so 3/7 plus 5 over x squared. LCD is what we kind of.
Mr. Isbell.
Yes, ma'am.
Caroline Benson checking out.
All right. So LCD, least common denominator, is what we've called that for years. And you know the difference in this and what you did in elementary school, so just got letters there instead of numbers in the denominator. So what would be the common denominator between a 7 and an x squared? Yeah, you just multiply. If they're not alike at all, you just multiply them together and get 7x squared. So the least common denominator is 7x squared. And that's going to give you, what do they turn into? So if this needs to be 7x squared, what does it need to turn into? All right. So 7 needs what? Needs the x squared. So if the bottom needs the x squared, the top also has to have it. Okay. So we're going to multiply by x squared, top and bottom. So that's 3x squared over 7x squared. The second fraction has the x squared, so it needs the 7. So if the bottom part needs it, so does the top part. And 7 times 5 is 35. And now it's back to a problem like we just finished. We already got the common denominator now. 3x squared plus 35 over 7x squared. Does the numerator factor? No. If it doesn't factor, then there's no way that's going to simplify. Only other thing that you could check would be the 7 go into each one of them. And it would need to factor for that to happen anyway. So there's our final answer. Once we get to the part where we're actually having to find the common denominator, the odds of them simplifying goes down quite a bit. There's not as likely to be simplifying problems. Let's look at this one. Let's say we had, what letter are we on? G. 8 over x parentheses x plus 2 plus 9 over x. And we want to find the least common denominator. And the way that I think about this and the way that I approach finding the least common denominator is I look for the things they have in common first. Other people do it a different way, but this is the way I do it. It seems to work pretty well for 20-something years. And so what do these two problems have in common? An x. So that's got to be part of your least common denominator, is the part they have in common. What part do they not have in common? That x plus 2. Now, the first fraction, does it have everything that's in the least common denominator? Yes. The second fraction needs what part? An x plus 2. Okay, so the bottom part needs x plus 2, so that means the top part needs it as well. So whatever happens to the bottom has to happen to the top as well. So we're going to multiply the bottom by x plus 2 and the top by x plus 2. I'm going to distribute on the top, but I don't worry about multiplying out the bottom. Never multiply out the denominator for me. Now, we're adding two fractions that have the same denominator. So what goes together in the numerators? What parts of these go together? You got 8 over that stuff, and then 9x plus 18. 8 and 18, they're what? Like terms. So we're going to put the like terms together. So we got 8 plus 18. So it's going to be 9x plus 26 over x plus 2. We have to check to see if it'll simplify, just like you would any normal number fraction. You'd always look to see if you can simplify it. This one, 9 and 26, do they even have anything in common? Pull out? No, they don't. So that's done. Toughest one we've had so far. Oh yeah, they're about to get tougher. Okay, notice that the denominators are written at every step here in factored form. What do you do if they're not? Like this one, 7x over x squared plus 3x minus 3 over x plus 3. All right. When I look at that denominator, I don't worry about the numerators. When I first get an adding and subtracting problem, I need to, in fractions, I look at the denominators first. What do we notice about the very first one? It's x squared plus 3x. It's quadratic. So our first instinct should always be to factor the denominators. Always. Because that's going to help us see what parts it has. So if I factor that, what's it going to factor as? X times x plus 3. So now it looks a lot like the previous example. If I look at the factored form of that. What's the shared piece between the two fractions? The x plus 3. So I know that's part of the common denominator. What is the other part? This x that's here. Okay? This one already has both pieces. This one needs which piece? It needs the x. So I'm going to multiply the bottom and the top by x. When I do that, I'm going to end up with 7x over x plus 3 minus 3x over x plus 3. I've got the denominators the same now, and I can subtract. If they're like terms, put them together. 7x minus 3x would be 4x over x plus 3. What does that simplify at all? What cancels? That x on the 4 and the x in the front. These cancel each other out. 4 x plus 3. Always looking to simplify at the end if possible. All right. Let's go even a little bit more difficult than that. So far it's been fairly tame. So let's go a little bit more difficult than that. 7 over 9x squared plus x over 3x squared plus 3x. What should our first instinct be when we're dealing with fraction problems? Doing what with the denominators? Factor. Factor the denominators as much as you can. First one's just got one term, so there's not really any factoring to do with it. But the second one, how could that be factored? GCF of 3x, right? And an x plus 1. Now, this one's a little bit more difficult to get the least common denominator on. Because what does it share? Nothing quite as obvious as the past few had. But this has a 3x. Is that related to 9x squared? Yeah. 9x squared is actually 3x and then another 3x. Right? It's 3x times 3x is 9x squared. So the shared piece is the 3x. Okay, so that's a shared piece. And then this one has another 3x, because that's what we want to think here, is that this is 3x and 3x. So the shared piece is this 3x and this 3x. This one has another 3x. So our common denominator's got to have a second 3x. And then the piece that this one doesn't even have at all, the x plus 1. Okay. So our common denominator is really 9x squared times x plus 1. That's really what that is. Because if you multiply those two together, that makes it look a little simpler when you put it together like that, right? Okay. Now, what does this one need? It needs another 3x to make it 9x squared in the front, right? So that's what we're going to multiply top and bottom by, is another 3x. And that's going to get us 3x squared on top, and then 9x squared times x plus 1 on the bottom. What does this fraction need? The x plus 1. A little bit easier on that one. So we're going to multiply x plus 1. X plus 1. Top and bottom. So that's 7x plus 7 over 9x squared x plus 1. Not a whole lot I can do there as far as combining like terms. There's actually no like terms that I can put together. So I'm just going to write that out as a polynomial on top. Trinomial, in fact. 7x plus 7 over 9x squared x plus 1. Now, I don't think it'll factor, but I've got to try to see if it will. So I would try my x method on the numerator. 3 times 7 is 21. Is there anything that multiplies to be 21 and adds to be 7? 7 and 3 are the only things that multiply to be 21, and that adds to be 10. So that definitely does not factor. So I've tried to simplify it. It doesn't, so I stop. I'm done. A little bit more difficult one there than what we've been seeing. Let's say we had x plus 3 over x plus 4, x minus 1, minus 2x minus 5 over x plus 2, x plus 4. So a subtraction problem and a little bit more complicated denominator. So when we go through the motions of the getting the least common denominator, what's the shared piece? X plus 4 is in both of them. What does this one have that one doesn't have? So the first one has an x minus 1, the second one doesn't have it. So that x minus 1's got to be part of the least common denominator. What else has to be part of it? Yeah, that x plus 2. So it's just everything that's in the denominator is our least common denominator. You don't need more than one piece of any part of it. It makes it more complicated. So what part of the LCD is the first fraction missing? the x plus 2. So we're going to multiply this one by x plus 2 on top and bottom. The second fraction is missing x minus 1. Multiply top and bottom by x minus 1. Okay. So to save myself a little writing here, I usually just, once I start to get into denominators this large, I'll just write one big fraction and put x minus 1, x plus 2, x plus 4 down there. Because they're the same on both of them. So I'm just going to write one big fraction. The first part, what do you do here? You multiply it out, right? It's distributive property or FOIL method, whichever way you learned it. X times x, x times 3, 2 times x, 2 times 3. So that's x squared plus 5x plus 6 minus, now here's a big thing. Since it's a subtraction problem, we're subtracting this entire numerator, not just the first piece. So I always put a set of parentheses next. If it's addition, it doesn't matter. It's not going to mess it up. But because it's subtraction, it's very important that you remember that you're subtracting that entire numerator, not the denominator, not just the first piece. So here, 2x times x is 2x squared minus 2x minus 5 minus 7x plus 5. 2x squared minus 7x plus 5. Next thing we do is just get like terms together with subtraction. So that'd be negative x squared, positive 12x, and 1. I know there's nothing multiplies to be negative 1 as to be positive 12. I know that doesn't happen. So that's an easy one to say. I'm done. Big thing there with the minus sign in the numerator. Make sure you make a note of that. Put a star beside it, something, highlight it. That's a big thing. It really mess things up. All right. 3 more examples, guys. X plus 1 over x squared plus 4x plus 4 minus 6 over x squared minus 4. So, what do we need to do first? Back to what? Denominators. Okay, so back to the denominators. What does the first one factor as? Yeah, 2x plus 2's. And I usually don't write those like with the squared or something beside it because it helps me see it better if they're both there. What does the second one factor as? X minus 2, x plus 2. All right, now that's going to help us find the least common denominator, which they share what? 1x plus 2. And then we need the other parts. What are the other parts? An x minus 2. That gets this one. We've only used one of these so far. We need both of them. We need another one of them. Okay. All right. So, what does the first one need? Needs an x minus 2. I'm multiplying by x minus 2. The second one needs the other x plus 2. That's x squared minus x minus 2 minus 6x minus 12. And on that one, How did I get minus 6x and minus 12 for this part up here? I multiplied 6 times 2, but not just 6, but what? A minus 6 times both of them. It's distributive property, but since it's just a number there, I can just distribute the minus sign with it to keep me from having to write an extra step in there. And then the denominator is still that. Simplify. So it'll be x squared minus 7x minus 14. Does the top part, does the numerator factor on this one? Nothing multiply to be negative 14, add to be negative 7. Nothing does that, so you're done. Like I said, the likelihood of them simplifying at the end goes down the more work you have to do to the denominators. And I'd say that, having 3 pieces, there's a good bit of work on the denominator. Okay. All right. Let's do a couple examples of what's called complex fractions. And they're not complex in the sense of complex numbers, but complex in the fact of fractions inside of fractions. So, complex fractions. Why would they do that? I don't know. It's just to make you think a whole lot. So let's start with 5 over x plus 4 over, and I'm going to use a larger marker here. There's the big fraction bar. So that's the numerator is that fraction. The denominator is 1 over x plus 4 plus 2 over x. Now, the key to doing these is not trying to do it all at once. Do the numerator, any work that would need to be done on the numerator. Is there any work to do on this numerator? No, there's only one fraction up there, so we really don't have to do anything to it. But the denominator is 2 separate fractions. What we want to do is rewrite it as one fraction in the denominator. So it's an addition problem in the denominator. So we're going to work it like a separate problem. So what do we need to do with that problem? Find the common denominator. What would the common denominator for this part be? X times x plus 4. Good job. What does the first fraction need? It needs an x. What's the second fraction need? X plus 4. That's going to give us x over x plus 4 plus, well, let's just write it as one fraction now, plus 2x plus 8. And get my big marker here. And then this fraction up top is still the same. Let's simplify the denominator. So we got x plus 2x is 3x. So 3x plus 8 for x plus 4. And then the numerator is 5 over x plus 4. Big fraction bar. That big fraction bar is what operation? Dividing. Didn't we divide fractions yesterday? We're dividing this by that. How did we do that? Flip which one? The second one. The one on the bottom is the second one. And then do what? Multiply. So we're turning this division problem into a multiplication problem now. So we got 5 over x plus 4 times x over x plus 4 over 3x plus 8. Well, that's handy, because what cancels out? X plus 4 cancels X plus 4. 5 times X is 5X. 3X plus 8 on the bottom. And you've simplified a complex fraction by doing that. So it's the combination of multiplying, division, simplifying, and addition and subtraction. Those complex fractions are the combination of everything we've done so far. So Trevor, maybe that's why they do that, is so that you combine all those skills together to get one problem. Let's look at one more. 6 over x minus 5 is the numerator. Denominator is 3 over x minus 2 over x minus 5. Then I'll do a large marker to do that. Okay. So is there any work to do on the numerator here? Okay. But there's plenty of work to do in the denominator. What's the common denominator in the denominator? Be x and x minus 5. So what's the first fraction need? Needs x minus 5. Second fraction needs x. Okay, so we're getting fairly quick at doing the easy ones. So 6 over x minus 5 over, and then here we got 3x minus 15 minus 2x over x minus 5. And maybe you want to skip that step of rewriting the simplified version, just go straight to the multiplication step. So you got 6 over x minus 5 times x over x minus 5 over, and then just simplify that right there. So 3x minus 2x is 1x minus 15. So we've taken it from addition, subtraction here to this, and now we've just, instead of the division, we wrote it as a multiplication problem by flipping. Cancel what'll cancel. X minus 5 is cancel, and we got 6x or x minus 15. They're not too bad to you in algebra 2 as far as the complex fractions go. You get into college algebra, they're going to do a little bit more with the numerator, a little bit more with the denominator, a little more work out of that, but still a decent amount of complexness to those fractions. Okay, so tomorrow's a work day. We're going to work on page 586, 3 through 36. Let's do 4 through 36 even this time. Because these do take a little while once you get into them. We'll stick with that for now and go from there. That's going to put us having a quiz on Monday, but that's okay. We can handle that and go from there. Okay.